I welcome you all for this wonderful session. Myself Shamchandar, Application Engineer representing EGS Computers India Private Limited. This is the agenda for today's session. Now let's see what we can do for an automotive industry to effective our design and validating the automotive related components. The component which I have chosen is steering rod and ball of group and rally car. Now let's see how to draw this steering rod ball. This is the SolidWorks window. By clicking new, we will get the list of part, assembly and drawing. Now just choose part and click open. Now just within a click of second, just choose the front plane. Now we can also get a line through mouse gestures. We can convert this solid line into construction line within a click away. Now as per the dimension, let's draw the sketch. Now by choosing smart dimension, we're gonna give dimensions for the component. And we can also change the unit right away. After drawing a straight lines, choose arc option. In that, choose 3-point arc and choose the 2 points to make an arc, and finally choose the point. Now go to features. Here we can choose a revolve feature. So in the revolve feature, now we made that component into 3D model. To add additional material, just click the plane. Give the dimension for the inner circle. Now go for extrude option, where we can add materials. So in the directions we can choose through all or mid plane according to our requirement. So the material has been added successfully. Now for the fillet option, choose fillet and choose the edges where we need to put the fillet. Now choose the radius for the fillet, then click OK. So we have successfully drawn the component. Now save the file in the desired location. Now we have successfully drawn the component. So in that we can simply initiate the workflow, and the SolidWorks drawing tool is easy to learn, and the interfaces are very good. Once you make changes to the component, it will be automatically updated. And we can also include some standards like bolts, fasteners to the component, and whatever component we draw, if we are going to use it repeatedly, we can add into the design library too. Now let's see how to make part drawing. Just choose make drawing from part, so we don't need to open from an additional file. Just clicking this option, we will get an window where we need to choose the paper format. Now I'm choosing A3. So once the format we get in the task pane, we get the list of views. I'm going to choose the front view. So the right view and the trimetric view. So now to make the dimensions, we have an option. So in that we can automatically include dimensions for the entire model. So these dimensions can be moved according to our views and requirements. If you want to include some sectional views, we can do that. Just drag and drop the line where you need a sectional view and click OK. We'll get a sectional view of that component. And if we have any bill of material, we can include that bill of material, and we can export to Microsoft Excel format, so that we can send it to material database. So once any changes has been accounted in the part design, it will be automatically updated in the drawing. We can avoid drawing errors, and we can production quality detail drawings can be included. Now let's see about e-drawing. This is the e-drawing file. So e-drawing file is mainly used for communication to your customer or to your boss. So the one you viewing this e-drawing file doesn't want to need an SolidWorks file. If he has any app called e-drawing, he can view that. He can also view in their phone, like Android or iPhone, there is an app. If they download it, they can view this component. Not only that, they can also rotate the component, pan, and if there is any multiple assembly, we can do the animation, and even we can see the sectional view of the component. Then if the customer requires any changes, he can include that through the markup option. So he can write the comment, for example, the fillet size is not required, or I need a bigger fillet for that one. And if the customer is satisfied with component, he can seal this. Like we have list of options, like approved means he can choose approve like this, so that once the designer opens the SolidWorks, he will get notification like the customer has approved this component, you can go ahead with. Next we are going to see about simulation. So simulation is to validate the component, whether the component will meet our requirement, whether it can withstand the load we are going to apply, and how many times or how long it will apply. What will be the factor of safety can be determined through simulation. So I'm gonna open the file. Okay, so this is the bracket of an steering car. So in this we need to go for add-in option, and we need to check in the SolidWorks simulation, then click OK. Then we will get the simulation tab, and by clicking new study, we will get the list of simulation options available in SolidWorks simulation. In that, we are going to choose static. In SolidWorks simulation specialty is it has a very simple 5 steps: applying material to the component, and boundary conditions like fixtures and the loads, and meshing the component, then running the model, then viewing the result. So now I'm going to apply the material property for this component. So SolidWorks simulation has a huge database of material properties. By choosing alloy steel, we will get the material property required to run this model. So the elastic modulus and Poisson ratio, which are marked in red, are the compulsory material data required to run this simulation. So by clicking apply, the material will be uploaded, and the tick mark shows the material property has been successfully uploaded to this component. Now fixtures, by clicking fixed geometry, we can fix the component. So in external load, we have a lot of categories like pressure, gravity, everything. Now I'm applying force to the rod and ball. I'm applying 600 Newton. So then meshing the component. I'm just meshing. So now meshing has been applying to the model to run the simulation. Now the model has been measured successfully, and the result is the stress variation, and we also get stresses like displacement and the strain and factor of safety. In the stress, we have the maximum and minimum annotations. Not only that, we can also change the unit for the stress values, and we can change the location of the result table. So in this, we can change this floating value to scientific or decimal fractions to whatever required values, and we can probe the result. So if you want to know what is the stress level at particular location, we can choose the probe option, and we can view. We can also view it as a graph, and if this data is very important for us, we can also export as an Excel file for further clarifications. And the factor of safety, so this is the maximum and minimum factor of safety. The factor of safety should always be more than 1, and we have a factor of safety of 1.2. so this component is good to go for the applied load. And SolidWorks simulation as a special feature of a report. So by clicking a report, we will get an customized Word document of whatever the study we run, and what is the boundary conditions, and what are the mesh data and model specification will be in the document. So through simulation, we can calculate the strength of the part and assemblies, and finding the factor of safety, and what is the peak and overall stresses of the model. Summary. So through SolidWorks, we can easily design a component which is very useful for automotive purpose, and we can visualize the result, and we can easily communicate that result to our end users through e-drawings. And with SolidWorks simulation, we can validate the product and whether it will be up to our requirement or not, so that we can reduce the prototype cost and overall time which it going to take to reach the market. So these can be controlled through SolidWorks solutions. For any query and clarification, kindly contact us. Thank you, ladies and gentlemen.